So good evening. In this video we'll be learning ETFund and we'll be learning circuits under DC network theorems. So we have different types of theories and analysis on how to find our voltage and currents. So under DC circuits we have the following topics that we have to cover. That's Thevenins theorem, Norton's analysis, nodal analysis, star delta circuits, where we have to change, maybe a circuit is in star, you change it into delta, or when it's in delta you change it into a star circuit just for you to find your resistance, current or voltage. We use superposition theorem and mesh analysis, and also we have to know how to find the maximum power transfer theorem. We can also use that one. So we'll start with Thevenin's theorem. So Thevenin's theorem states that any linear circuit can be simplified into an equivalent circuit comprising of a single source voltage, that's Thevenin's voltage, and a series resistance. A series resistance, that's Thevenin's resistance, and the load resistance that you are finding the currents for. So we have a linear circuit here that has a voltage source, another voltage here, another voltage source here. You have R1, R2, and R3. And then this circuit here, linear circuit, can be simplified into a Thevenin's equivalent circuit with one single voltage source, that's the Thevenin's voltage source, and then the Thevenin's resistance and the load resistance that you are finding the current for. Yeah. So we'll jump straight into an. So the question reads, using Thevenin's theorem, find the current in 8 ohm resistor in the figure below. Given that the battery has an internal resistance over 1 ohm. Yeah, so this is our linear circuit that we've been given here. So our voltage source here, our battery, 440 volts. It has an internal resistance of 1 ohm. Here we have 3 ohms, 5 ohms, 6 ohms, and then in between A and B we have an 8 ohm, the one we are supposed to find the current for. So redrawing the circuit, after redrawing the circuit, we have to open up. We make it an open circuit. We remove the 8 ohm resistor. After removing the 8 ohm resistor, that means we'll have no voltage drop on our 5 ohm resistor. That means the voltage in between the 6 ohm resistor is equal to the 8 ohm resistor. Yeah, so this is our equivalent. After reducing, this is our circuit. So the first thing that we'll do, we'll find the we have to find the current in the circuit. So we'll only consider this loop here. Yeah, considering this loop here, we are going to get our voltage and then our 3 ohm resistor, 6 ohm resistor, and our internal resistance for the battery. So taking that into consideration, we are going to have our current here is equal to our voltage source over our internal resistor plus R1 plus R3, which is equal to 40 over 1 plus 3 plus 6. So 40 over, this is 9, 10. So the current in our circuit is 4 amps. This is our current. And then the next thing that we'll do is we have to find the voltage across this 6 ohm resistor. since this 6, we don't have a voltage drop here on a 5 ohm resistor, simply because it's an open circuit. So the voltage drop will be here on the 6 ohm resistor, which is equal to the 8 ohm resistor. So we have to find the voltage drop for the 6 ohm resistor. So finding the voltage across the 6 ohm resistor, what we are going to do is, we are going to say we are going to multiply 4 amps, the current in our circuit, multiplied by the 6 ohm. That will be 24 volts. This is our Thevenins voltage. This is our Thevenins voltage. You can either write it as VTH or ETH. So this is our Thevenins voltage. That means the voltage, the Thevenins voltage that's here, it's equal to the Thevenins voltage that's on the 8 ohm resistor. Yeah. So right now we have our Thevenins voltage, the one that we are going to put in our equivalent circuit. The next thing that we have to do is now we have to find our Thevenins resistance. So for us to find the Thevenins resistance, we have to redraw the circuit. So when redrawing the circuit, remember they said that our battery has an internal resistance of 1. So we have to include it. So we've included the internal resistance of 1, the 3 ohm, the 6 ohm, and the 5 ohm. But you have to leave, we have to still exclude the 8 ohm resistor. We leave it open. So looking at the circuit from this point of view, you can notice that 3 and 1 are in series and parallel to 6, and then in series with the 5 ohm resistor. So what we'll do is we'll say 3 plus 1 is equal to, that's 4. So since it's equal to 4 ohms is in parallel with 6, so we'll say 4 times 6 over 4 plus 6, plus it's in series with 5. So our answer will be, if we multiply this and then we add this and you divide, you add it to this, it will be 7.4 ohms. You can try that on your calculator and then you let me know. So since right now, looking at what we've done so far, we have our Thevenins voltage source. Our Thevenins voltage is equal to 24 volts. And then we have our Thevenins resistance, that's 7.4 ohms. And we have our load, the one we are finding the current for, that's the 8 ohm resistor that we are given. So we can now redraw our circuit, our equivalent, Thevenins equivalent circuit. I'll just use my free hand. And so this, we have our Thevenins voltage, that's what, 24 volts. We have our Thevenins resistance, that's 7.4 ohms, and we have our load resistance, that's 8 ohms. So we can find the current across the 8 ohm resistor. So we're going to have Thevenins voltage over, we have Thevenins resistor plus our load resistor, which is equal to 24 over 7.4 plus 8 If you can punch on your calculator, the answer should give you 1.56 amps. Yeah, if you punch that, the answer should give you this. So looking at what we've done,